probably begin lecturing. So unlike the previous few days' lectures, this one's not quite as nitty-gritty within the code aspects of it, so I think you'll probably enjoy that a little bit more. I've thrown in as many memes as I possibly can into these slides. But unfortunately, before I can cover APIs and async directly, I of course have to give adults motivation because we are lazy. So, to kind of motivate the ideas of APIs and async, let's first think about how we send information across the world. Sadly, we can't just like email each other every individual code file and things like that. Git is a marvelous thing, but when we try to access information, there is one thing, especially within our web browsers, that we use more often than anything else. And the big hint I'll give you is it's at the beginning of every single one of our address bars, whether we like it or not. So who can tell me what those letters are?
HTTP?
HTTP, or its lovely, more secure cousin, HTTPS, but they're practically the same thing for our intents and purposes at this moment. And so, the HTTP is short for Hypertext Transfer Protocol, but that doesn't really matter to us. And what more matters to us is its purpose and why it was made. So it allows us to request and respond with information. And so these engineers, they sat around for God knows how long developing this protocol on how we send and receive information. And some guy probably at like 4:04 in the morning came up with a lovely idea for HTTP. And so HTTP really allows us through all of our lovely browsers, different as they may be. We are lovely Chrome fanboys, so you can sit right at your laptops with your Chrome browser, send HTTP requests to Facebook, Google, whatever it may be. And then you can do that on Firefox. And then you can do the same thing with Safari, though I don't really recommend that personally. And even worse, you could try and probably fail doing the same thing with Internet Explorer, which is why we are ultimately Chrome fanboys. If they have to use all of our information, they can. I don't really care. But yeah, so ultimately what those engineers came up with at 4:04 in the morning was this lovely diagram of sorts. All HTTP requests, responses are sort of made up of this body in some shape, form, or fashion. You have your request URL, you have your HTTP method, your headers, and your body. So first and foremost of those four lovely things is our HTTP methods. We've talked about a few of them, but of course in true web lab fashion, we've just casually mentioned them and left them for another lecture or later. So of course, our first method that we talked about quite a lot is our GET request method. So it's aptly named. It's just trying to request getting information from whatever server. The one I don't think we've mentioned yet is POST, but this allows us to create information. So whenever we're trying to make posts on Facebook, apparently I can't think of any other company than Facebook today. So when we're trying to post information to Facebook, make posts, make stories, whatnot, we just simply find our endpoint and we send a post request to it. Additionally, there are other HTTP methods, including put and delete. They're a little less common, but put allows us to modify data. If we've posted something and we don't quite like it as it is, we can send a put request to change it. Additionally, delete allows us to, well, delete the requested resource. There are quite a few other HTTP methods, but they're much less common, and so if you so desire, we also are MDN fanboys in that we provided the link to the other HTTP methods. But there were still other parts to that HTTP diagram. So the other parts, including the request URL, be it facebook.com or whatnot, that just simply tells us where we want to send our request. Fairly straightforward. The request body allows us to provide information for our request, such as what exactly we want to create with our post request. Obviously, if we just send, hey, I want to create something, their servers are going to be like, what do you want to create? That's not very useful. And so we additionally have to send what we wish to create along with that. And the request headers allow us to do a whole lot of fancy stuff, including authentication for requests if it's somehow restricted. Tell us what browser we're navigating from, but that's really more high level than we want to deal with. So on the other end of the spectrum, we have responses. And responses, for the most part, are identical to requests, except they have the magical ability of having status codes. And generally, they also give us what we wanted. I would hope so. So status codes generally fall into categories of 100, 200, 300, 400, 500, somewhere in that lovely range. You've likely seen a few status codes. Can anybody tell me a status code or two they have seen? We'll go to you first.
404.
404 is definitely one we've seen. Do we have any more? Any more audience engagement? We can be as awkward as we want today.
401.
If you want to list them all, you can try.
200.
200, okay. Well, so yeah, we've definitely seen a lot of them. The first one you mentioned, 404. It's not fun trying to find web pages, especially with broken links. Finding 404 is not a fun time. But we also have 200 okay, as our lovely friend mentioned. And we also have server-sided errors, because even server developers are not perfect. And of course, we have blurry 2000, 16 memes now? 400 bad requests. But, so all of those, generally the numbers tell us something about what went wrong. So 100 errors are informational of some kind. 200 errors are the ones we want. These are things like 200 okay, 201 created, things like that. So we also have redirect errors. If you've tried to go to a URL that is relocated in some form or fashion. We have 400 errors, which is generally you did something wrong. Whether it be you try to navigate to a page that doesn't exist, you sent a request but didn't give all the information that the request required, things of that nature, and then there's server error where you didn't do anything wrong, so you're perfectly fine. Unfortunately, that does not help you access the page anymore. And of course, there are a few other lovely requests, lovely status codes that are listed there, including a few meaty ones. Twitter has created the status code 420, enhance your calm. There's also the status code 418, I'm a teapot. Just whenever they wanted to make status codes, they just felt like I would make a status code for meeting purposes. But generally, you're only ever going to see status codes of three of these kinds, hopefully. If you see 100 status codes or 300 status codes, you probably didn't do something right. So you'll likely see these 200 status codes, the 400 status codes, and the 500 status codes more often than not. And so when sending these requests, we obviously have to send them somewhere. We can't just send them to Facebook.com itself all the time. Generally, we want to send requests to a specific portion or endpoint of a site. And so endpoints like to take different types of requests. So here are a few endpoints related to our finished cat book. So if you so desire, you could type that right into your browser bar, the GET request ones at the very least. And you would see the response, generally in a JSON format, of the cat book stories. But not necessarily all requests are, not all URLs, not endpoints are fully unique. They can also be divided up into the specific type of request. So in our finished cat book, we'll have our lovely API comment, which depending on what type of request you make to that specific URL, will have different outcomes. If you make a GET request, it'll show you the comments, and if you make a POST request, it'll try and create that comment, which you can see by making a GET request to the same endpoint. So now that we have endpoints, we know how to make requests, we know the status codes, we can actually make a couple requests and see how they go. So I provided a couple links within the slides. So here I've tried to make a request to weblab.mit.edu/yeet. Now, of course, this specific endpoint doesn't exist. So as we can see kind of over here on the side, that we get, as we expected, a 404 not found, and according to the lovely engineers that develop HTML and HTTP, we get a lovely simple HTML page telling us that the requested URL /yeet was not found. I find that far more entertaining than I should. And additionally, we might want to see a request that actually works. I'm sorry for anybody that actually speaks German in the audience, but it was one of the only ASCII arts I could find with a direct link. So we have these German giraffes. I just decided I would get the most random thing I could make a GET request to humanly possible. So this is apparently some joke, but I've been too lazy to translate it. So have fun with that. Maybe that's homework. Just translate this German joke. But yeah, so now that we have endpoints, we have requests, we can actually dive into APIs themselves. So APIs, they're more of a buzzword. Their definition exactly has kind of been confused with a lot of developers because we just throw the name API pretty willy-nilly generally. But APIs themselves are really just a set of endpoints with which we can make requests to for our services. Now that's pretty general, but to be more specific, a lot of companies provide APIs such as Google, Amazon, Facebook even. They'll provide APIs to allow us to access their services without necessarily us having direct access to their databases. I mean, I would absolutely love to have direct access to Facebook's databases. That would be absolutely amazing, but totally a security breach. But unfortunately, I can't have that access, so instead they just give us APIs with which we can make more secure, not totally legal access to the databases. And so I wanted to give like a concrete example of an API. So a lot of restaurants utilize APIs in their websites to implement Google Maps support. So Google Maps is one of probably the most popular API within the web development community. So I just Googled local restaurants because I haven't left my room all that much this semester, so I don't know just a ton of restaurants. But apparently this is one that exists in northern Boston. On their website, what do you know? They have Google Maps right in the middle. So the web developer that created this probably doesn't know a lot about location services and how to track people across the world, but they probably do know a little bit about basic web development and APIs. And so he doesn't have to have this great leap in knowledge, he just has to know how to use this API. And, well, bam, you can have Street View in the middle of your restaurant. And so that brings to kind of the purpose of APIs, is you don't necessarily, there are a bunch of types of browsers we saw with the clients and servers. There are a bunch of operating systems. Lord knows I've had all the fun in the world helping you with your MacBook Airs. And we want to avoid these errors. We want it to be the same for every single person. We want to provide access to our services for every person the same way each time. And so the API acts as kind of a layer in between our data, our servers, everything of that nature, between the clients and that. So that's really all they do, is just provide a universal standard set of ways to access data through GET requests, POST requests, delete requests, all of the type of requests. The APIs just provide endpoints that are exposed, and we can make requests to them from anywhere in any shape, form, or fashion, so long as we conform to the requests that the API has opened. You obviously can't make a POST request to a delete endpoint and expect it to work. That being said, API calls are actually fairly straightforward, believe this meme or not. I just stole the blurriest memes from Google image absolutely steal. And so we can actually take a look at APIs and what they return. So APIs are the voodoo magic of backend that we haven't really seen too much of. We did cover React and things like that. But so one fantastic API visualization tool that I like to use personally is Swagger. So Swagger will take your APIs and its endpoints and help you kind of visualize what it is. So here Swagger has a demo API that they've provided. And within it, they have a bunch of different requests for all of their data and things like that. So if this were an actual API with actual data in the background and things of that nature, we could theoretically make requests to this and get access to pets and their store, their inventory, things of that nature. And if I wanted to advertise this pet store somewhere else, I could use this API to talk about their stuff without necessarily having access to their data directly. And so generally requests take a certain type of information. So in this GET request, we have IDs that we access. And of course the API can return specific status codes on successful operations or be whatever error they decide to return. And so that ends kind of the API portion. Does anybody have any direct questions as to APIs, their purpose, their function? None, okay. Well, that's just lovely. Anyways, but so now we get to go to the latter half of that title, async. So async being short for asynchronous. Everything we've covered up until now has pretty much been synchronous. We haven't really had just a great leap in async so far. But what the synchronous implies is that every line of code that you call will finish in the exact order in which they were called. The next thing can't go until you've finished what you call. But in the async world, that doesn't necessarily have to happen. If you call something that takes a lot of time, the next thing, if it doesn't take so much time, the next thing can be called and might finish before your first thing finishes. And of course, I'm not the greatest speaker, so I have a graph. So this graph will show kind of async and synchronous, but even still, I don't think quite this graph is enough. We can throw some concrete ideas to it. So let's say that this red one here is we make some form of GET request for data. And while that request is going, you have fingers of lightning, and in the milliseconds that request happens, you also press a button that changes color. Now, if we did it synchronously, your button press wouldn't be processed until that GET request finished. And so we don't we want our sites to be responsive while things are loading in the background. JavaScript really allows us to, it was built for the web, of course, in such that it allows async functions and things quite readily, so that we aren't constantly lagging behind because things are loading because the internet is a perfect and totally not broken place. And so, of course, if you still don't quite get async, maybe you can get it through the power of memes. Everything works through the power of memes. This father apparently, they don't quite get what no or maybe is. And so your maybe will eventually turn into no. And additionally, of course, I find the blurriest images humanly possible. I tried to sharpen it as much as I could. But, so 10 things you'll find shocking about asynchronous operations. 3, 2, 7, 4, 6, 1. I'm just bad with numbers at this point. But, so we talked about what async is, we talked about why it exists, but now we can talk about how to actually do asynchronous code. So here we have 4 lines, 4 very basic lines. We're just going to log the letter A, we're going to make a GET request, and then after that GET request is finished, inside, we're going to make another log of get. And then we're gonna do B and C. Well, it's probably misleading for me to say and then. Because I want you to place your bets. What order will those finish in? So option one, we have A, the get, B, and C. Let's see some hands. What percentage do you think option one will happen first? No way, okay. What about option two, A, B, C, and then the get? How many of you think? We got 1, 2, 3, 4. I'm not gonna count that, that's too much effort. Okay, what about option three? Nobody for option three. Option four? Nobody for option four, okay. Well, it turns out you were all correct. It does indeed go in the order of A, B, C, and then your final get, because the get takes absolutely forever. It takes absolutely no time to log something to your screen, but it does take a little bit of time to make the get request to the random ASCII art German page. It takes time, so that's why the order happens in that specific way. But if we go back a step to that lovely async thing we did, so we've only made one sort of async type thing now, but if we were to do a whole bunch of async things together, it would get quite ugly. As before, let's say we had something that relied on this console log, for instance. If something relied on that console log, we would have to wait until the console log finishes before we can do the next thing. So with only just one thing, it might not seem all that important, but if we chain together a whole bunch of things that relied on each other, the code would become quite ugly in a nested mess. So fortunately, somebody invented the lovely idea of promises. So promises allow us to make things quite pretty. So it also has more functional purpose other than just prettiness. It makes error handling much, much easier. Because if you have a nested mess and you try error handling the nested mess, unless you do a lot more effort, your nested error catching will probably just catch everything within that jumbled mess. And so with promises, rather than making the data rely in a nested system, we can just say, hey, let's do a lovely GET request, and then we can do something. So promises are, as their name implies, they're just a promise that we will get something done. So your data doesn't quite exist yet. Promises have 3 lovely states. They can be pending, fulfilled, or rejected. Of course, we never want rejected promises because nobody makes broken promises. So what will happen here is that this GET will have a lovely request to, I was too lazy to come up with an actual link, so I just came up with memelink.com. If that's an actual site, I apologize. We'll have that, and then we can log the status code for that response. Hopefully it's a 200. But if this request failed in any form or way, then our status will probably end up, that promise will be rejected and our status probably won't go so well. And so that can bring us to a really basic recap. So HTTP is how we send all of our information, so essentially it's our backbone for our web. Methods and status codes are incredibly memeable. If you ever do become a developer at some high-up place, please make an HTTP status code meme in honor of me. That would be a lovely dream. And the internet would be really lame because you couldn't do any advanced feature without APIs because you would have to be knowledgeable in like 70 different subjects all at the same time. And I don't know about you, but my 3 brain cells are struggling just to do this lecture alone. Async saves us a lot of time, but in really small amounts because, I mean, synchronous calls, they only take a few milliseconds at a time, hopefully, and never break your promises. And so that's all I've really got. For now.
Okay.
Any questions? all. Oh, we got one.
So I'm kind of confused by like the syntax of a promise. What does the arrow mean?
So that arrow was just for a function.
Okay.
So that wasn't necessarily related to the promise itself, but so the GET request promised a response. And so we can take that response as a parameter for the function console log. And so we directly use response status from the promised response.
Okay. All right.
Okay.
How do you force that to be synchronous if you want?
So GET requests themselves can't be synchronous because that would just be absolutely terrible. Yeah, just for all intents and purposes, don't try and make that synchronous. Don't try.
If you want to make it synchronous, something you could do though is like you could have inside the callback function for the GET request, you could put your console logs. So that's the way that you force things to be synchronous is you want to take your first operation, call it first, and then your second operation you'll put inside the callback of the first one. And then you keep on nesting it that way.
Okay.
It's terrible.
Questions document is view only.
Sorry. Reload.
Any more questions? API related or not?
So when you were showing the API request, it said text plain. What does that mean?
So when we do requests, there are, of course, data types that we can send. You can send just plain text to an API and it will try and do its very best to parse that in something it can use. But generally a lot of APIs will use what's called JSON. It's another lovely format of presenting variables and things like that in a readable fashion. Love it or hate it.
Question? When you're calling asynchronous promises, does the browser like actually implement the code in? Does the browser actually run the code in parallel?
Well, yeah. So, I mean, you can only run so many things at a time. In modern systems, yes, we have lovely multi-threading and things like that. So, generally, yes, if you have to, it's still waiting on that response. And waiting on that response still takes a little bit of processing. So, yeah, it's not exactly all located in one single thread, one single operation. So, there is some parallelism going on. Nothing more? No, looks like I'm done.
Sorry.
I'm blind.
I have a question for what it means when it says console.log response.status. So does that mean it pulls out whether this promise is pending, canceled, or rejected, or does it actually print out?
So response.status is actually a field within response itself. So this is not necessarily related directly to election per se, but the status field holds the status code of the HTTP response. So it's just a straightforward, simple way of logging out whatever for debugging purposes or whatnot, or error handling, things of that nature. You can say like if response.status is not in a 200 range, then figure out what the heck went wrong. Am I blind still? Yes.
So why do we use console?
So it ultimately makes things prettier. So as he alluded to earlier, when we try and force things to be synchronous, because if they weren't necessarily synchronous, errors are plenty. When we try and force things to be synchronous, they nest, and so eventually, if you nest things enough times, like you have code way out here when you started your first callback way over here. And so promises For the most part, allow just prettifying and then error handling on top of that. Other than that, they don't really have a true directly functional purpose in that way. It's by developers for developers.
Also, like, if you're making a promise to get data and you want to do something with that data after you've got it, you can use a promise to then wait for the data to come in before modifying or using it.
You think of a promise is like a placeholder. It's like, here's a thing that we went to get, and it might not be here yet. And then once it comes here, then do this, right? So it's syntactically nice so that you have like a placeholder in your code for something that will come to you in the future, hopefully. That's why it's called promise. You don't know if it's there yet or not.
But we promised it would. Also, it's like kind of nice in the Python sort of sense, like it reads like a sentence. Do this, then.
If in the code I did console.log get, what would happen?
Just directly?
Yeah.
Well, if you're talking get as in a string, then it would just.
No,
This variable.
the variable, not the log.
So if you just did the get itself, it would try and log a promise to the screen. So in the Chrome's development window, it would literally just show kind of in italics promise, and then it would probably tell you whether it's been rejected or fulfilled.
No, you can also show people, like, the network speed or how it shows it's actually using.
So what happens if I ignore the wall of red text? Yeah, here we have two lovely requests that were made when this page was loaded. Well, it would be great if. So as we can see, requests are being made all the time, and we can see the status codes kind of on the side here. It would be great if I made this larger. That might be a little too large, but we'll make it work. This lovely waterfall bit can show us things overlapping in an asynchronous nature. So these two requests, as they aren't quite parallel, but they are certainly concurrent. And these requests are obviously all in their lovely async nature, overlapping and this and that. And we have our status codes and the time they took, and requests are happening all the time, even in very, very, very small amounts.